go. Ladies and gentlemen, girls and boys, I'm Alan Willison, and it's my pleasure to welcome you to this meeting of the Hartford Astronomy Group. We've got a really lovely evening ahead of us with our guest speakers and other presentations, and I'm sure you're going to enjoy every moment of it. Just before we get started, a few usual housekeeping rules. For those of you down in university, can we ask please that you double check that your phones are on silent or vibrate so that they don't disturb anyone in the meeting? Also, we're not expecting to practice the fire alarm tonight, so if it goes off, it will be for real. So please leave the building carefully, sensibly, assemble on the car park, and we'll check you there to make sure everybody is safe and sound. For those of us on Zoom, if I can ask you to keep muted, keep your hands away from the space bar so you don't accidentally switch yourselves on in the meeting. And I'm sure you're going to enjoy what you'll see from the university. The format of the evening is that after these short announcements, we'll be passing over to Martin, who's going to tell us about things which are both visible and perhaps invisible in the sky. And following Martin, we will pass over then to Jerry, who's going to introduce tonight's speaker. And I'm sure this is going to be a fantastic talk. Following the talk, there will be a chance to ask questions. For those of you in the university, we will ask if you can put your hand up and somebody will come to you with a roving microphone so that we can all hear it. For those of us on Zoom, if you could submit your questions through the chat facility, they will be read down at the university and given to the speaker. So, after the questions, just a few closing remarks from myself, and then that will be it. We aim to finish somewhere between about 9:30 and 9:45. So I'm now going to pass you over to Martin, who's going to talk about the night sky. So over to you, Martin.
Yep, okay, brilliant. Good evening, everybody. It's lovely to see so many people turning up to our live talks. So it's really nice. So, and hello to those on Zoom also. I'm going to talk a little bit tonight about the comet, the green comet, that has been in the news just recently. I don't know if any of you tried looking for it so far, but it's not easy to spot because it is very faint. But for those that I might have a telescope or a pair of binoculars, I've just put a little bit of information up here of where it's going to be over this month. So if you have a look on there, we can see that it's, at the moment, we're probably almost just gone past Capella, which is quite a bright star. And we're probably, in the next couple of days, it's going to be level with Mars. So if you can find Mars in the sky, you should be able to spot it, but it is very, very dim. I did go out the other night to have a look, see if I could find it, and I couldn't see it. And I knew where it was. So, with telescope, it shouldn't be too bad, especially if you've got an app that will let you find it. But there's a little bit of information I put up there about the comet. Comet E3 is now one of the closest points to Earth. Although the comet was nearest to our planet last week, passing within 42 million kilometres, it still will be visible to the end of the month. So it gives you a chance to catch it. So the last time it was in our skies was 50,000 years ago, so it's not a regular visitor. So if you get a chance, and say at the moment the only downside is the moon is really bright, so doesn't help matters too much. But there we are. That's the course up to the 21st of February. So this is a picture of the comet that Steve took. So might come out pretty well. May not show too well blown up on the screen. It looks good. So you see why it's nicknamed the Green Comet, because it is very green. So we've got a very active astrophotography section here. So Steve as one of the founder members of the astronomical side, with myself and a few other members. Dennis, who's with us, runs the HAG, and anybody's interested in astrophotography, have a chat with Dennis at the end, and he'll give you some information about it. So this one is another one of our astrophotographers Michael took of the comet, which slightly bigger image, but quite nice to see the nucleus of the comet there. Moving on. So I'm going to talk a little bit about what's to look at in the night sky this time of year. So at the beginning, this is a predominant sights in the southern sky at the moment. The Weeping Sisters and the Hades star cluster. The Weeping Sisters is just another name for the Pleiades. Most people can spot that because although they're quite small, they're very bright. But they're in Taurus. Hades cluster is not so easy to spot, but if you can find this yellow star, the yellow star here, I haven't got a pointer, in the circle there, that's Aldebaran, and that is part of the triangle. You see the triangle there, Hades. But if you look at that through a telescope binoculars, there's absolutely thousands of stars there. It's quite a sight to see. So the Aldebaran is actually the eye, one of the eyes of the bull. I'm moving on a bit. So the next thing, as it's February and we've got Valentine's Day coming up, I thought we'll talk about the Heart Nebula. The Heart Nebula is located in the constellation of Cassiope, which is the W you see in the sky. It's very popular with astrophotographers because it's quite bright, and there's quite a bit of oxygen in it, and sulfur gases and hydrogen. So, if you're using filtered astrophotography, you can get a lot of colour out of it if you're using those filters, the oxygen, the sulfur, and the hydrogen filters. There you can see the dust lanes within the nebula. Although even though we've got a full moon at the moment, but I have got some images of the nebula that have been taken by some of our members. So there's a nice picture that Kevin took of the Heart Nebula. And the centre section now, you can see with the pillars, is an area of star birth. So you've got new stars that are lighting up the dust clouds within the centre of the nebula. Thank you, Kevin, for that picture. Brilliant, if you're watching. So, we've got a few planetary conjunctions coming up. So this one here, Mars, Venus, and Neptune, and the Moon. The planets and the Moon are putting on quite a show, as it says here, several conjunctions. First up is the close encounter between Venus and Neptune on the 15th of February. Now, Neptune is so far away, it's very difficult to spot without a well, you won't see it without a telescope, to be honest with you. Yeah, just be careful if you are using a telescope, and I mean this is quite low down, that the sun has gone down completely. You need to be very careful with the sun and normal astro telescopes that don't have filters to protect you from the sun, so just be cautious of that. But there we are, we've got Jupiter fairly high still, Venus and Neptune closer to Venus. So moving on, a week later, 22nd February, we've got another conjunction with Venus, Jupiter, a very thin waxing crescent moon, so that'll help things with visibility a bit. Makes a small triangle in the southern western sky. So we've got Jupiter, the moon, and Venus there. So that's one to look out for. And then on the 27th of February, we've got Mars and the Moon will appear to be near each other in the south. Obviously, they're not really near each other, it's just the conjunction. Mars is obviously a lot further away than the Moon. So they're they'll be at their highest point at 1900 hours and be visible till 2 o'clock in the morning. So you can see where we are there. This is Orion's belt here, and Orion Nebula, and Orion, so Orion's belt there and the nebula there. I really must get a laser pointer or something. Okay, so Venus and Jupiter will also appear to approach each other on the evening of the 28th of February in the southwestern sky. Again, the sun's just gone down here. Be very careful with telescopes. But yeah, they're both two of the brightest objects in the night sky, so really you should be able to spot them quite easily. So, I'm moving on to some images now. I always like to throw some images from our astrophotography section. Michael is fairly new to the club, but his images he's taken are absolutely superb. This is the Cone Nebula, which he's taken on a mono camera and used filters to bring in the colour. So the SHO palette stands for, well, it's sometimes called the Hubble palette, but the SHO stands for sulfur, hydrogen, oxygen, because those are the filters that actually filter out all other light other than that particular emission from the stars. So the stars, when they hit certain gas, they excite the gas and it gives off light at a certain wavelength, and we can filter that out, and that's what gives us the colour. So this one here was taken by Steve. This is another very bright nebula, the Rosette Nebula. Again, another area of star birth. In the very centre you can see stars born and the dust clouds that are supplying the material for the stars to be formed. Again, that's been taken on a colour camera rather than using a mono camera. This is another one by Steve. These, we were talking about the Pleiades earlier on. This is a spectacular picture of them. Now, the nebulosity you can see around the stars is actually not where the stars are. It's actually quite a few light years in front of it. The stars are just shining through, coincidentally shining through the nebula, and that's what's lighting it up and giving that effect. But these are very young stars, only a couple of million years old, which is babies in stellar terms. They're very hot, white and blue stars. Another one by Kevin. This is the famous Horsehead Nebula and the Flame Nebula in Orion. So from Orion's belt, where the Orion Nebula is, if you come up to, there's 3 stars in the belt. So the star, as you look at it, to the left-hand side, these nebulas are just below that star. So if you do have a camera on a mount and you point at that, this is quite a wide field shot. But he's got some fantastic colours in there. He shows all the material that is creating the stars here around the nebula. Steve took this last night, I believe. This is the Thor's helmet, because it looks like Thor's helmet. It's a helmet with the 2 wings coming out the side. Now this is a really difficult object to get. It's very low, for me it just barely skims the top of the houses when I'm trying to get it. But interestingly, the interesting about this nebula is that the nebula is caused by a Wolf-Rayet star, which is a very hot, short-lived star that throws off its material before it actually dies. It's not a supernova or a planetary nebula where the stars actually die. The star is still alive, and the material that you're seeing there, that the star is lighting up, is what it's cast off itself. It's one of my images. This is the Owl Nebula. Actually, it looks a bit like an owl, doesn't it, with the 2 eyes, which is hence its name. It's not actually a nebula per se, it's what we call a planetary nebula. And a planetary nebula basically is a sun very similar to ours, a star similar to ours. Doesn't go supernova, it becomes a red giant, and then it shrinks down and becomes a white dwarf, but all the material is thrown off into that sphere you can see, and then the white dwarf is actually lighting it up. So that's what will happen to our sun eventually in 3 or 4 billion years' time. Not that we're going to worry about that, I don't think. And this one here, last picture by Kevin. Again, this is another Wolf-Rayet star. This is the Bubble Nebula. For obvious reasons, it looks just like a bubble. But he's done that again on a mono camera. He's using the Hubble palette, which you use the sulfur element to represent the red, use the hydrogen to represent green, and the sulfur is the red, the hydrogen is the green, and the oxygen is the blue. And then by mixing the colours, you can bring out more definition. It gives quite a 3D effect, I think. And that is it. So, and if nobody's got any questions, I'll hand over to Jerry.
Right, good evening, everyone. Nice to see you all here. In fact, I'm seeing quite a few people this week. On Friday and Saturday, I was down at Astrofest in Kensington. Anybody here go there? I know some of you did. And this coming Friday is the February meeting of the Royal Astronomical Society, so I plan to go down for that. Astrofest are very good. They had some posters to give away, and I picked up a pile of them, which are here at the front, and you're welcome to take them. There's a large sheet showing what's going on in the sky over the year, and there's also a poster for the Messier collection. So by all means, go and pick those up before you leave. So this evening we're seeing a return from an excellent speaker who came to us some years ago now, Francisco Diego, and he is a lecturer at University College London and vice president of the Association for Astronomy Education and fellow of the Royal Astronomical Society. He is a keen popularizer of natural sciences and also is an extensive presenter in planetarium. Tonight, he's talking about his latest project, which is the Paradise Planet Earth. And he's going to talk about how this blends the natural sciences with the arts, philosophy, and ancestral wisdom. The idea, he says, is to provide an essential cultural tool for a united humanity to defend and preserve the natural environment. So please welcome Francisco.
Yeah, it is a pleasure to be here with you again and to talk about something which is a bit unusual to what we are used to do in our loving science of astronomy. It's a kind of very broad view of the origin of the universe, the origin of chemical elements, the origin of solar systems, the Earth itself, and how life started, and what are we doing with all that today. in a nutshell. That's what we're going to talk about. This is part of a project that I want to do for education, to train teachers, to bring all this to the national curriculum, because there is a pressing need to really become aware, but cosmically aware of the stupidity we are doing on this planet, which is far more serious than that we think. And that is the idea, to really shake and then take action, because we need to do something very drastically and very quickly. So, as an introduction, I will show you a few images of this paradise where we live. I'm going to go rather quickly because it's a very long presentation. It's just condensing all this project in a single presentation, but the project will develop in a website and all these topics will be expanded accordingly. A lovely place, full of life, full of diversity. And we ask, where is this coming from? How does it start? We have the myths and the creation myths. None of them are true, but this is what we are humans, and we cannot take. We have to have an answer to all the questions that we have. If we don't have an answer, we make it up, like the Chinese did with this big black egg, or the Egyptians with this lovely picture of several gods and goddesses. By far more attractive way of looking at the origin of the universe. The Greeks and the Aztecs, all of them were polytheistic. And then we have the Australians with the rainbow serpent, the creator of the world and the plants, animals, and humans. And we have in North America, the northern part of America. It's not the same as North America. It's the northern part of America. America, the continent, has a northern part and a southern part. The northern part of America, we have the Indians that came with Tawa, the sun god, and the spider woman. And they look at the Milky Way and look at the different landscapes here. Very symbolic, very good representation artistically of what the universe looks like. A more boring one from the Judeo-Christian in the Bible, God created the heaven and the earth, etc. And God said, let there be light, and there was light. So all these myths that are part of our history, this is a paradise, we're going to show the paradise later on, are not true, but we still hold them because we need to acknowledge what humanity has done in the past. And this is part of our cultural heritage. We have to keep them as myths, because now we move into something more complex. And we are going to examine, for the last few hundred years, we have gone into deeper and deeper into the nature of the world, the nature of the universe. And this is what we have done. D.H. Huxley was a contemporary of Darwin, and this couple of sentences here summarize very well what science is all about. And I would say not only science, it is almost applicable to almost any activity, any human activity. The two concepts of giving up preconceived notions, go with the mind of a little child, extremely important. Number one. And number two, humility. We have to acknowledge, get rid of our arrogance, and acknowledge that nature is by far more powerful than we are. Nature was there before we were here. Nature will be there after we leave. As we just said, the death of the sun will come, the solar system will disappear in a few billion years, and nature will carry on. There will be other planets, who knows. And then we will be gone, essentially. So we have to take this, and this is how we learn. This is how we go. And I am taking this analogy very quickly of water, the nature of water. What is it? What is the smallest amount of water that you can have? In these images of water droplets hanging from a spider web, that's 1 millimeter there, just to give you an idea of the scale here. These little lenses giving inverted images of the landscape behind them. Amazing. What's the smallest amount of water? So the smallest amount of water, we say, well, it's a water molecule. It has 3 particles, 2 whites, which are hydrogen, 1 red, which is oxygen. And then we say, well, how small is this molecule? We can have in a drop of water, we have how many molecules of water in a drop of water? And this analogy, perhaps you have heard it before, it's very important because the amount of molecules in a glass of water, we cannot count. How many molecules of water in that glass? We can calculate it. There are ways science tells us, and we get a number with a lot of zeros, so which doesn't make any sense. But let's try to feel the size of a water molecule. Okay, so this is a picture that symbolizes all the oceans on Earth. Pacific, Atlantic, Indian, all the oceans and rivers and lakes. Imagine all the water in all the oceans on Earth. And the analogy goes that there are more molecules of water in that glass than glasses of water in all the oceans on Earth. So let that sink, okay? It's a big number, but you can feel the size of that number. Imagine the amount of glasses of water in the oceans, okay? Amazing. And the water molecule is big because it's made out of smaller things. So there we go. And now the concept of getting things together, we're coming smaller and smaller, you see. We're getting into the components. We are going into what is smaller. How do you put hydrogen and oxygen together? How do you put them together to make a molecule? To assemble a molecule, actually. We don't make it, we just assemble it. And where do we get these atoms from? And what are they made of? You know, you go to the primary schools and the kids say, what is smaller than an atom? What is smaller than this? They want to get to the smallest and the smallest thing. And that is the triggering the curiosity, which is what you are trying to do. So we're building a paradise, and we have to go into the components of paradise, and we have to see how these components came to be, to assemble themselves into a paradise that we have here. Origins. I didn't bring my timeline that you probably have seen before, but what I'm going to show you is the development of the universe from what we call the Big Bang, which was not that big. It was tiny, 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 tiny. The emergence of pure energy out of nothing, violating all the laws of physics as we know them today. Obviously, there is a lack of knowledge there that we need to sort out one day. Who knows how this energy came to be out of nothing. But anyway, that energy is transformed into particles, and the particles get together to form atoms, and we're getting very quickly the steps. I'm skipping the quarks and the protons and the neutrons here. And then gravity brings together these clouds of atoms. Well, we have here hydrogen and helium, little bit of lithium, and these clouds are getting together by gravity to form the very first stars a few 100 million years after the Big Bang. The core of the star gets very hot. These are huge clouds of gas. I mean, there are millions of kilometers across, and that size makes them very compressed in the center, where the temperature goes to millions of degrees. And in the center, we have those conditions where the particles can get into larger and larger numbers, the particles that produce the nuclei of the atoms, that get together at temperature of hundreds of millions of degrees in the later stages of the life of the stars. We have here helium getting together to get beryllium. One more helium gives you, plus beryllium gives you carbon. One more helium plus carbon gives you oxygen. So this is what happens in the stars which are about to die. And the smaller stars, like the sun, is going to do in a few billion years when it starts to die. These processes will go there. It's a process of assembly. All these particles came from the Big Bang, and we are now assembling them together in stars. The stars have the processes. They run out of fuel, they run out of energy, they explode or they die in different ways. And during these explosions, we have the possibilities of temperatures of thousands of millions of degrees, which is temperature that we don't have inside the stars when the stars are still alive. And those temperatures come during the explosions of the stars. And this is where we get the heavier chemical elements like gold, uranium, silicon. And there are other processes as well. This is a very simplistic way of describing it. So on the left here is a very famous periodic table. On the left we have the chemical elements that came from the Big Bang. These are, give or take, I mean, the chemical elements which are synthesized inside the stars all the way down to number 26. There's a number of protons in the nucleus, 1 for hydrogen, 2 for helium, as we saw, 6 for carbon, and then 26 for iron. And then all the others after iron are produced after the death of the stars, during the death of the stars or afterwards. Especially gold, 79, which only recently we found that is produced by colliding. Isn't that amazing? I mean, colliding neutron stars. I mean, what? Colliding neutron. Look at your gold. And we're going to talk about gold later on, which is one of the main problems that we have on this planet. I wish we didn't have gold because that's producing all the disasters that we have. Colliding neutron stars. Anyway, these are very rare, very expensive because they are not abundant. They are produced in a matter of hours in some cases. It's very quick. And this is why they are so rare and so precious. The clouds that were forming stars came together again in a recycling process. This is a very famous picture from the Space Telescope with the trapezium, the Orion Nebula, when we see stars which are being formed and the atoms start to produce molecules. We have interstellar molecules, very simple ones here. There are far more. I mean, with the radio telescopes, we have detected molecules that have 15 or 20 or more atoms, including amino acids and other complex molecules. But then we have carbon monoxide, water, carbon dioxide, methane, ammonia, etc. So all this comes together to form new generations of stars, like we see here. These amazing pictures, the high-resolution pictures from the Hubble Space Telescope of the Orion Nebula. Do we have a picture like this from the James Webb yet? Hasn't done the Orion Nebula? No. It hasn't. Probably it's in the wrong place because it's in the Lagrange point, and then you have to wait until, because the sun is that way. I don't know. It should be. I don't know. It's a matter of you cannot see the whole sky. You can only see part of the sky in front of you, away from the Earth and the sun. Anyway, super high resolution, and we had even high resolution. We could see this formation of a star with the large amount of gas and dust comes to the center, where the material goes more compressed and hotter, and ignites the star. Leftover material is spinning around. It could produce another star, and sometimes it does. In the case of the Pleiades, for example, we have a cluster of stars. But in these cases, we have just leftover material that still gets together, accretes to form smaller objects with less mass that never achieves that temperature and then become planets. So that process, and this is very important to point, that process has been going on for thousands of millions of years in the whole universe. But we could talk about our galaxy. And this is well before the formation of our own solar system. So before the formation of our own solar system, our galaxy was producing solar systems for about, I don't know, probably 7,000 or 8,000 million years. Planets that preceded ours for thousands of millions of years. Okay? Planets, life, aliens, yeah? Millions of years. You get the point. Where are they? So, and those stars, of course, eventually follow the same track and then recycle themselves, and we come from that. So those beautiful, actually, this is the same nebula here that you have here, Jerry. The famous pillars from the Hubble, and now we have the James Webb with the infrared images there. And these blobs that came again together by gravity, and only a few 1,000 million years ago with formation of our own solar system. 4,566 million years ago, a number that we know because of the analysis of the isotopic ratios in meteorites. I didn't bring my meteorite now, but if you can get, you have meteorites, yes, you can buy them, and you can actually show them to the kids in school. This is the oldest thing you can hold in your hand. It's older than the Earth. So fascinating that we have achieved all that knowledge. Our solar system, a very violent place. There are collisions, meteorites, asteroids, and planets against each other. This is, as very famously, you may remember, the Earth and Theia that collide in a particular way. This is just an animation that has been tuned in order to produce the final product, which is the increase of the mass of the Earth, change of the internal structure of the Earth with two different cores, magnetic field, etc. Leftover material is in the sky right now. By chance. It may not have happened. It may have happened in a different way. If there was a head-on collision, both of them will be converted into a shower of asteroids. You realize that? That collision changed the structure of the Earth inside, gave a magnetic field, tilted the axis of the Earth, and gave the Earth a kind of rate of spin that wouldn't have otherwise. By chance. So they may have looked like this, with atmospheres and very thick atmospheres, kind of greenhouse bodies, similar to Venus. The gravity of the moon around the Earth keeps the axis of the Earth tilted with the same angle. Very important to keep a constant weather for millions of years. No other planet has that. I mean, Mars and Venus, for example, the axis is tumbling all the time, and the conditions start changing a long time. A greenhouse planet. Thousands of simultaneous volcanic eruptions, magnetic storms, bombardment by asteroids and comets, bringing water. This is not the green comet. Hale-Bopp, I think. Actually, all the comets are green, because the CO line, they're all green. I mean, this was specifically green, but they always show this green color in a way in the coma. Bringing water to our oceans, and that water is going to be evaporating because we are in a greenhouse planet. And we have the tides, another important thing, the tides produced by the moon. Producing pockets of water where the chemistry can develop into more complex structures. Or we can go, we're talking about the origin of life, where the chemistry, because life is complex chemistry, down in the bottom of the sea, because of this movement of the internal structure of the Earth, the plate tectonics and volcanic eruptions and all that we have on Earth, produces these black smokers, which is just kind of submarine volcanic eruptions, pumping energy and all kinds of chemicals there in the bottom of the sea, where life can flourish, as we can see with very deep submarines. We can detect the life forms there. Life may have appeared there about 4,000 million years ago, but these molecules eventually get together to form the very famous and beautiful structure of this acid that is present in every single living thing since life started on Earth. Everything alive has that molecule. Every single cell and everything alive has that molecule. The colors are representing different chemical elements. It's a very complex molecule. At that scale, that molecule will be thousands of kilometers long. And that's what makes it diverse and complex in a way. But it's very simple, because you see, yellow is phosphorus, red is oxygen, blue is nitrogen, white is hydrogen, and the gray is carbon. So we have 5 chemical elements, no more, in that molecule. Isn't that amazing? Notice how the yellow, the phosphates are in the outside, phosphates and sugars, and the base is in the middle. 5 chemical elements for all life on Earth. Since the very beginning, since the very first bacteria. A molecule that can replicate, can reproduce, and make copies more or less identical to the original one with some variations, and this is where the biology becomes interesting. A few 100 million years after the formation of the Earth, we have the appearance of fossil bacteria. We have fossilized bacteria detected in the rocks in Greenland and Australia, and we have these kind of packets of DNA and RNA and other complex molecules encapsulated in membranes. The very first life that that life was bacteria that could have this green color, blue-green color, the cyanobacteria, the blue-green algae that had the property of photosynthesis. So they started to play with the atmosphere of the Earth, which was very rich in carbon dioxide. And with the photosynthesis, with the little light that was filtering from the sun, they started to change the atmosphere of the Earth. That process took thousands of millions of years. So the Earth was, could write the Bible. I mean, in the beginning, the Earth was hell. There's no question about it, okay? And that hell became a paradise, thanks to the photosynthetic action of the cyanobacteria, the blue-green algae. And it's still doing it today. Wipe out the carbon dioxide, release the oxygen, atmosphere becomes transparent, the liquid water on the surface is preserved, and now life can go into another step. Because bacteria on their own, they cannot do much. It's a dead end for life. And this is another important concept, because there is life like bacteria that may be very abundant. Probably on the moon, we will find fossilized bacteria, certainly on Mars, in the moons of Saturn and Jupiter. There will be this kind of life, because there was water there, and is still today, in the oceans of Europa or Enceladus, there may be some kind of primitive life when we go and melt our way through the crust of these places. We may find some kind of evidence for life, or fossilized in the case of Mars. Now the step from bacteria to this kind of cell, which is far bigger and far more complex, that has internal structures. In fact, some of these bacteria are inside here as chloroplasts and mitochondria and the nucleus itself of this cell. And then we have a cytoplasm. We have internal membranes. These are called prokaryotic cells because they don't have a nucleus. That comes from the Greek. Karyon means nucleus, prokaryon, and this is eukaryotic cell. That step happened only once in a single place on Earth. Not that long ago, about 1,000 million years ago. And it is very difficult. It's almost a miracle. People working at UCL, Professor Nick Lane, who is working on this origin of life, calls this the eukaryotic revolution. Almost impossible. So this is easy, it happened very quickly. This is difficult. And these are very delicate. They need very special conditions to survive, while these ones are very resilient. This makes life that we can see without the aid of a microscope. To see this, you need a very powerful microscope. So, the eukaryotic cells, hundreds of millions of years ago, we have the very first life that appears. We have, using the metaphor of Darwin of the tree of life, we have all these branches that symbolize different species that are flourishing in the oceans. And then we have massive extinctions by chance. We don't know about this one 260 million years ago. We don't know. It may have been this, may have been volcanic eruptions, but we know that 96% of life on Earth was made extinct from the fossil record. And we know that. 90, no, it's not 95, no, 96. And we know that. We can see the fossil record stops. What happened there? Massive extinction, we don't know exactly what, because the Earth is very dynamic. There is plate tectonics, there is water, there is erosion, there is atmosphere, volcanic eruptions, etc. Or any evidence is erased all the time. So after millions of years, that's gone. But the tree of life, very resilient, it grows again. The branches will be different by chance. Still the tree of life, but different branches. All the ones that were, 96% that were extinct, they are not there anymore. New ones will come, including, of course, dinosaurs and the age of the dinosaurs that started from about 200 million years ago until, very famously, this poor Brontosaurus was going to be, together with 76% of life on Earth, obliterated by a massive extinction again. From this one, we do have evidence. We have the evidence of the crater, which is in my country, Mexico. That was Mexico. I mean, at that time, Mexico, I mean, America and Africa and Europe were together 65 million years ago, and then separated. But after that extinction, they keep separating because of plate tectonics. But anyway, in that place, still with a remote sensing from space and radar, we can detect the crater, which is the size of Clavius. When you see Clavius, it's about 240 kilometers across, one of the largest craters on the moon. Well, that's the size of the crater that was made on Earth, that made the dinosaurs, and 75% or 76% of life on Earth extinct. By chance. It may not have happened. Instead of 75%, could have been 90, could have been 40. By chance. The asteroid could have been bigger. This one was 10 kilometers across. It could have been bigger or smaller. And there is an idea there were two asteroids actually. I was reading recently. There were two asteroids actually that produced this massive extinction. By chance. And this is, you see what we are doing, building a kind of conditions that are pointing to where we are now standing on this planet. Any of these things missing from the history, we wouldn't be here. Now, on this paradise now that has a transparent atmosphere, has gone through massive extinctions, this is where the mammals, after that extinction, have a chance to flourish because they were there with the dinosaurs, but the dinosaurs were repressing them. So this is a new tree of life that comes from that extinction, and the mammals start to develop, and in a few million years ago, we start coming to see the primates, eventually the apes and monkeys and apes, and we are apes, and that is what we have today as a Homo sapiens that is very young in the history of the Earth. It's not even a million years. Homo sapiens is about 300,000 years. And our solar system is more than 4,500 million years. So that is, remember T.H. Huxley, humility? That's a kind of humility, the amount of time that we have in here. So this is many trees of life you can find. All of this is microscopic, all this is microscopic, and then animals and big plants are here. That's the core data, the ones that have a spinal cord. And here we have the apes and the monkeys, and here's where we are, there, or there, for example, there. That's a kind of sense of humility. And we are there by chance. And we come from there because humankind has a common origin in that part of Africa. Amazing picture of the Apollo 8 coming back to the Earth after going around the moon. And they took an image of the cradle of humanity, humankind. Something that, in general, is not part of our culture, floating around, that Homo sapiens is not inevitable. It could not have been. There are many species of man that became extinct. The Australopithecus over there, Homo habilis, Homo ancestors, rudolfensis, all these kind of dead ends for humans. And then finally we have the antecessor, and then the Erectus became extinct. From here we go to Heidelbergensis, and then we have two branches here. One is the Neanderthal that became extinct a few thousand years ago, and Homo sapiens, which is what we are. But we are standing on all these kind of failures of humans. It is important to acknowledge that. Migration. We come from Kenya, Tanzania, and migrate to the rest of the world, everywhere, except Antarctica, everywhere. Only a few thousand years ago, we were all like that, all of us, our ancestors were like that. Every single person alive has an ancestor like this. We were all black. All of us. You get the point? We were black. We lost our color, the ones that came to different latitudes, because as we migrate, these are thousands of years, okay, 100,000, 40,000, 50,000, and this is America, coming through the Strait of Bering only a few thousand years ago, which is not that much. It's the most recent migration, maybe from Polynesia to populate the southern part of America here. That's a possibility as well, because this going through the central part of America is not that easy. It's a very straight area, which is very difficult to walk, but it could have been migration. Now, these are solar radiation on the Earth, the high levels of solar radiation, and the lower levels as we go away from the equator towards higher latitudes. And this is the same, representing the skin color. You see? If you are born here, you need darker skin color to protect you from the UV radiation. If you go away, your skin becomes lighter. And that's what happened in thousands of years. That was what happened. It's only one race, really. And I keep saying I have to Photoshop. This is taken from the internet, but the black should be in the center because that's the original one, the source of all the others, and the white has to come on one corner. I should do that in Photoshop at some point, or make my own. It's only one race. We are identical. Below the skin, the blood is the same. Thinking is the same. I mean, give or take cultural influences of thousands of years. But we are identical. And look at the chemical composition. As we said, well, this is DNA essentially. Plus we have the calcium in our bones because of vertebrates. So we are not that different from dinosaurs in the way of abundance of chemical elements in our bodies, which is fascinating. This is science. No myth of creation can tell you this. No way. And this is by far more beautiful and more true and more uplifting in a way. Makes you part of the whole thing. So we share the DNA with everything to the level of 50%. And between the apes, gibbon, orangutan, chimpanzee, gorilla, and man, because we are apes. I mean, we live in the planet of the apes. Forget about those films and all these things. This is the planet of the apes because we are apes as well. There are 5 apes. And we share the DNA with the chimpanzee to the level of 98.6%, even more, because that number has been growing. So we are almost the same. Let alone all humankind. I don't know, I should put more 9s here. I have to do proper research and see how many 9s are there. We have the same code, give or take a few. Yes, taller, smaller, color skin and color eyes, etc. But we are essentially the same. Now we come to the problem of what we are doing, because these migrations, we have here the Americans that came from Asia, populated America 12,000 years ago. The Europeans came from Africa as well, a shorter detour from Africa 40,000 years ago, populated Europe, and only a few hundred years ago took the ships across the Atlantic and met here in the islands of the Caribbean. And it was a tragic encounter. The so-called Indians were here already for 20,000 years, and only a few hundred years ago we have the Europeans coming, also from Africa in different way, and they come and they met again in these islands. They met again, and they failed to recognize each other, obviously. But they came from Africa. Now we know that. And look at the tragedy. This is a beautiful mask by, I think it's Inca, of pure gold. For these so-called undeveloped savages, the gold was a ceremonial metal, almost sacred, nothing to be bought and sold. And that was the problem, because they saw this, and still today. Let's have a look. They came with their own culture, and they obliterated the previous cultures here. This is in Mexico. That's the Catholic Church, and these are the temples of the Aztecs, and the gold. So, what are we doing because we want that gold?
I'd never looked beyond the sun before you showed me the road.
all that is happening in the last few hundred years, after 4,500 million years of making this paradise. We are very efficient. So, yes, we say, what do we do? How do we do this? How do we clear up this mess? Well, the first thing to do, you ask a child, why don't you just stop doing what you are doing to start with? Instead of thinking, what else can you do? Because you don't want to give up. You don't want to give your gold. I want to keep the gold and I want to fix it. No, you give your gold, you give all your things, and then we are talking. We don't want to do that. We cannot sit on the negotiating table with nature. So we need to stop, and we come to this imperative need of change drastically and quickly, because nature will do it for us. And if nature does that, nature doesn't have feelings or emotions. There will be millions of people being a nature genocide, if you like, because nature has to carry on. So let me finish now by showing you what we call the planet. It has a very thin atmosphere that will be about this thick at that scale. The space station will be here, going around the Earth. Actually, this way, sorry. All the water and oceans and all that glasses of water I was talking about, the average depth of the sea is about 3 or 4 kilometers, I guess. Remember, there is more water in Europa than in the Earth, because Europa oceans are 100 kilometers deep. All the water on Earth will be that much. And if we have the fresh water on Earth, the one that we really need, will be that much at that scale, a little kind of bubble of water there. That really makes an impact. So let's call to the ancestral wisdom, because they knew, they felt nature. The cultures that were almost destroyed completely by the Europeans that came to America. And all this wisdom is from them. There is wisdom in Australia and in other places as well, of people that didn't have science, but they knew how nature works. They knew what is overexploitation. They knew how sacred water is. The main gods in America, the main god is Tlaloc, which is the god of water. So, no pressure. We have a challenge, and we have to take it. There is no excuse. Every single of us has to do something about it. There is no excuse. So we are going to schools with showing the structure of atoms, the structure of molecules with the polystyrene balls painted of different colors. Even they made a periodic table with biscuits here. But just to get the science going, and yes, bring telescopes and microscopes to the classrooms to really investigate the beautiful part of nature that is missed by most of the population because we don't have that. And you know, in our, I saw a very interesting, you know, IQ Square, that series of talks in the Emmanuel Center. They have an interview and a kind of debate between two science fiction novels, two dystopias actually, 1984 and Brave New World. And in those, one of the conclusions there is that in these dystopias, people are taking away from nature. Isn't that what is happening here? That we are being taken away from nature. That is a struggle to go outside in the field, not for us, but to go in the fields and look at trees, look at the stars. People don't do that anymore. We are now concentrated in our little distractions, especially the younger generations. Pretty soon they will know what a tree is, let alone the star, well, let alone the Milky Way or the star or planet. That is a disaster. That's the killing of the thinking ability of humanity. Humans are thinking machines, and we have to preserve that. Otherwise, we are not humans anymore. Beautiful poem. Tiger shining. Anyway, you remember all that. And the kids come with their own ideas, and they write their own conclusions. These are spectroscopes looking at emission lines in a lamp. They could be emission lines in the comet, for example. So, yes, that's what we need to do. I'm going to stop here. I'll show you this image here, which has a few possibilities of collaboration with different institutions. It's just a random selection there. But essentially, we need funding, we need activism, and we need to join forces with other people like these ones that are doing lovely work. See if you have any comments, any ideas. Sorry to throw you that straight away like this, I'm firing. But see if you have any comments. I don't know how are we going with time. It's 10 past 9. If you have any questions, send in the back, please. Thank you.
Hi, really amazing presentation and touching, to be honest, at the same time. I would like to ask you about, because you go for education in the end, and I think I strongly believe in this, but I think there must be some kind of trick there in the sense where we go through some kind of social revolution, how we perceive world. And I don't really know, how can you do it? Is it a time frame that is so important? Is it us as a whole? You know, but because whenever kids look at us, they take so much from us, and we are really bad example in that sense. So what we should do, because whenever we go, we will say education, this is very broad and very limping in some sense. What we can do to actually to inspire them that, as you said, we are the one. We are one thing together, and together actually somehow as a unity we can achieve, let's say, this paradise in that sense. So what is exactly, where can we utilize this amazing ideas to inspire new generations?
Yeah, exactly. That's the challenge. As I said, no pressure, but it has to be done. And we are talking 8,000 million people on this planet. So it's not easy with different cultures. And look at what's happening in the world now. Have you heard any mention of peace in this process in Ukraine? Nobody talks about peace. It's just pumping more machinery into the war, making business essentially, killing people in the process. Not their people, the people that are living there. I mean, that's, I don't know. I wish aliens existed and then they came and have a look at this and they will sort it out quicker. Anyway, it is a major problem, but I agree with you. It is, and the problem is that we are short of time because that some of the images I showed the Amazon when you see on the distance, that's very recent. That's in Peru. It's the Peruvian Amazonia that is being mined by gold, is mining gold and leaving behind all kind of very nasty chemicals, mercury and all kinds of metals. That land, it cannot be reconstituted. It's already contaminated forever. You cannot clean it. And then we still keep doing it. And then we overthrow governments in that part. Actually, in Peru, it's happening right now because we want to keep going. These mine companies from the United States and from Canada are doing that. Because of the gold, we want more and more. For what? So, yes, it's a major challenge, and we have to join forces. There is a lot of people that are working on this. There is one called Teaching the Future, which is not here. Teaching the Future is a beautiful organization, but it's good to start trying to join forces with them. And as I said, we are short of time because by 2030, most of the Amazon will have gone. So it's a race against the destruction. That's what I put in that image, is you have to stop. Where is the United Nations, for goodness sake? I mean, who measures the United Nations today? They don't do anything. They don't have power. If I was Secretary General of the United Nations, I'd say, hang on a minute, stop burning trees. That's it. That's it. And I have the power to do that. I have the blue helmets, and they will do that. Send the blue helmets to the Amazon, and then no more burning, no more. And now we're going to do, okay, but not more of this, that kind of stuff. Because otherwise, it's going to disappear. Production of plastic, same thing. Stop the production of plastic. There is technology to produce proper plastic that can be recycled, and they can be properly, with proper systems, not these blue bags that appear everywhere on the planet. Let alone the face mask from COVID. I don't know how many are there in the ocean already floating around because they are difficult to destroy. Anyway, yes. Any more comments? Thank you for that. And yeah, it's, yeah. Desmond Tutu and Nelson Mandela, the southern part of Africa, they have this concept of Ubuntu, that I cannot be happy if you are not happy. I cannot be happy if nature is not happy. This kind of solidarity, which is, what is solidarity? Have you heard of solidarity? Not anymore. Solidarity with ourselves and solidarity with nature for the whole of humanity. Yes, please.
Hello, thank you. What a great talk. That was really inspiring and educational as well. My question is, if we're running out of time, I think it's great that you're trying to educate children, but we need to educate adults, I think. We have less than 12 years. I think we're a third of the way into our time that we have to peak emissions. The Amazon is becoming a source of carbon now. It's reached that tipping point. And I'd like to know if you have any ideas for that.
Well, yes, thank you for that. People who are committing these crimes, they know well. They don't need to be educated. They know what they are doing. They just want the gold. They don't care if people are killed in the process. If you destroy the Amazon in the process, who cares? You get the gold. You see, so they know exactly. They know it's a very valuable planet. They don't care. That's the problem. They are criminals, essentially.
There are also a lot of kids that know exactly what's going on, which is why they're on the streets.
But when you mention the adult education, it's essentially families and the parents of these kids, because a lot of education is in the family. Yeah, absolutely. But we have to do something. Okay, cannot just sit there and then see the thing burning and say, oh, sorry, what can you do? That's it. Yeah.
My question is, you've mentioned gold a few times and saying that gold is such a key driver. There's so many different commodities in the world
listen,
that are so responsible for...
It's just a symbol, okay?
You use gold as a symbol.
It has a lot of ramifications.
Yeah.
You can say...
It can mean palm oil.
Minerals, palm oil, I don't know, precious minerals, etc. Yes.
Yeah, because that makes sense, because at the end of the day, gold is a symbol for money, and they're exploiting all of these other resources to get money in gold.
Maybe it should be lithium now.
That was the tragedy of the discovery of America. You see.
So you just mentioned the discovery of America. I read a quote somewhere that America wasn't discovered but actually stolen. But the point I did want to ask was that you mentioned the world population a few minutes ago. Surely that is the underlying problem. There are too many people on the planet, and of course everybody aspires for a decent lifestyle. And there is not enough resource to equip everybody with what they want.
I disagree completely. There is plenty of resources. Listen, I don't know, Oxfam has these numbers. I don't know what the number is, but just to give an idea, 2% of the population of this planet control 98% of the resources. They are the hyper, mega, super trillionaires on this planet. There are plenty of resources. How much food is wasted just to keep the prices down? Or to you see? There is plenty of food. The distribution is the problem. But yes, certainly, the population growth is a problem. We need population control. That's fine. Yes, family planning, yes. But there is still plenty of resources. I haven't done the numbers, but I would like to do that. If I was the dictator of this planet, remember that, you see the Great Dictator with Charlie Chaplin playing with the ball and the music of Lohengrin of Wagner, and then he's the dictator and he owns the world. I will say nobody on this planet can earn more than $100,000 per year. That's a lot of money. No more than that. That's the top.
Yeah, I disagree with that. No,
hang on, I haven't finished. Yeah. Nobody can earn more than that. Now you take all that money that comes on top of 100,000, which are millions and millions and millions and millions and millions, and the yachts and the mega this and the other, you get all these resources that can be distributed, and make the numbers, but you can give, I don't know, $1,000 for each citizen on this planet.
That's missing. That doesn't understand what money is. Like, money is debt for future labour. Right, so when people say that someone's got trillions in the bank or billions in the bank, they don't, right? It's a debt, right? The money doesn't actually exist, right? It's a lot more complicated than
Listen, just take the principle of it. I don't go into the details of the subtleties of this. It's the principle, it's the kind of mentality, okay? Why do I need 20,000 homes with swimming pools and helicopters and private jets and mega, I don't know, spend $1,000 million in a yacht?
100 grand doesn't do that, right? It's all relative to
We can talk later. Yeah.
Sorry, can I say,
yeah.
You said £100,000. Is that a number you just plucked out?
Yeah, for example.
Sorry, let me finish. This gentleman is entirely right. You haven't got multiple helicopters, you haven't got multiple yachts on £100,000. You're doing very, very well. So you said £100,000. Why not 150,000, 200,000, or £50,000? Why 100,000? Where did you get that number from?
It's just
But then it's just a number you've pulled out of the
I mean,
air.
it's 100,000 instead of $1,000 million.
But if you're going to give a number, you need
If I
to
give you
go-
$500 million,
Sorry.
what do you do with that?
Sorry, if you're going to give a number and it's going to cure the problems of the world, because I must say, your talk was very long on we have problems, very short on solutions, which was basically education, which I'm not against. But if you're going to say a number, I think it's fair to ask you to justify that number.
Well, I said, what number of money, salary annually, will give you a decent life? Okay. That you are not suffering, and that is a very generous. My salary, if I had full-time in college, my salary will be £45,000 a year, which is plenty. I don't need that money.
First of all, you have to define what a good standard of living is. Secondly, £100,000 in the heart of New York. You're comfortable, but you're not rich. £100,000 living in
Listen,
parts of the world, you
that
must-
comes with the change of society. New York doesn't exist anymore in that concept. We have to change our mentality. That's a whole thing. You don't understand. So, I'm sorry, I'm not going to continue this discussion. I'm sorry. Yeah.
Is capitalism the problem?
Yes.
Oh, no, it's not.
Absolutely. Absolutely.
I'll tell you why capitalism isn't the problem, right? Right, the reason we have anything we have, right, is because of technology, right?
Who do you say we? How about the thousands of millions in the southern hemisphere dying of hunger, and the children that don't have they don't have clean water? No way. Do you say we? That is selfish.
No, I'm going to explain why. Right. We had over the history spinning wheels, you know, the engine, the weaving machine, everything of technology that gives us our wealth. Okay, right? All of that, right? The vast majority of that wealth came from people wanting to be rich. We have Facebook. Facebook is free. Right? Twitter is free. The reason we have all of that technology is because there were people that said, I want to be rich. And because they wanted to be rich, they allowed everything we have in this society is because of technology. Otherwise we go back
Because
to
it has been
3 and 3.
stolen from the southern hemisphere.
No,
Stolen
it's
gold,
invent-
cheap labor, child labor.
No. Labour is one form of the thing, right? But technology, the inventions to do something, right? To actually make a shirt, right? To have a shirt built 100 in a day versus 1 in a day by manual labour, right? That is what creates wealth, right? It's being able to create things, right, that allows things to be so much cheaper.
You need to travel around the world, actually. You need to travel.
Oh, come on, people here have travelled.
Yeah.
And how many people were starving in the third world as a proportion of the world population 50 and 100 years ago compared to today? We are feeding more people today than we were 50
About 40 years ago.
Go to Africa. Go to Africa and tell the same thing.
Now's probably a good time to wrap this one up. It's getting very heated. So if we could possibly...
Gentlemen, enough. Enough. Sit down.
Thank you very much.
Everybody, quiet now. Thank you.
It's 9:30. It's probably about time for us to wrap the evening up. So if I can hand over to you, Jerry.
Thank you.
Okay. Thank you. Thank you very much, Francisco, and people asking questions, making comments on that. It's certainly been quite interesting. As we said, it's now at 9:30, so we do need to wrap up. I just want to mention that the Council for Protection of Rural England is having this year's star count coming up. I think it's from the 17th to 24th of February. And the idea is that you find somewhere, preferably away from street lights, and you look up at Orion. And Orion's easy to spot. You've got the 4 main stars around the outside and the 3 across the belt. The idea is to count the stars within the 4 outer stars. So you count the three of the belt, but not the outer ones. And the question is, how many stars can you see with the naked eye? And if you look up Star Count 2023, you'll find a page where you can then submit your findings. And the idea is that this is being done all over the UK, and we can get a spread of knowledge of how our night skies are. Now, is Alan going to show the poster? Apart from our meetings, we have other activities, and there's one special one coming up in which we are holding one of our evenings where we'll be offering help and advice on astronomical equipment. So if anyone has a telescope and they want some help with it, or they're thinking of buying a telescope or binoculars, then you need to come along, particularly if you're having any trouble with your equipment. So this is called My Telescope Doesn't Work, and we blame the equipment, and that's taking place on Saturday the 25th of March at Bramfield Village Hall, which is between Welling and Hertford. So details of that will be on the website. It is going to be free, and you're welcome to bring equipment along, and there'll be people who can help you with it. And there's free parking nearby, and I think we're going to have some refreshments as well. So it's 25th of March at Bramfield Village Hall. Okay.
Lovely. First of all, I would like to express our sincere thanks to Francisco. What a terrific talk, and to show just what we have done to the planet, but also giving us guidance about where we can head to save it. There was a question popped up actually on the chat, which asked basically, should we sort of let ourselves get extinct and let nature carry on? That's a very interesting way of looking at it. Nature will have a way of reinventing life, as we saw earlier in Francisco's talk. So very many thanks to Francisco from all of us out here in Zoom and those of you down at the university. I'd like to thank Jerry for talking about the star count and also about the telescope not working. We'll get those details onto the website for people to take notice of them. To wind up, I would first of all like to thank the team that's made this evening possible, the committee, tech groups, ticket sales, admin, finance, all those sort of things which go on in the background, hardly noticed, but certainly we want to say thank you to all of you for a really fantastic presentation. Must say, actually, I think it was quality of the sound was probably the best we've ever had. So well done indeed, team. And finally, just to say, our next meeting of the Hertford group is on the 8th of March. This is the study of protoplanetary disks in the 2020s. So that's going to be a terrific one. It's by Professor Kathy Clark, who came to us in, I think it was 2017. So she has been to us in the past before, and I can promise you that's going to be a terrific talk. So on behalf of Hertford Astronomy Group, I'd like to thank everybody who came along, whether you're at Zoom or at the university. Thank you for coming along and supporting us, and we look forward to seeing you in the future. So that's goodbye from me, and we look forward to seeing you again. I'll stop the meeting here, and those of you on Zoom, if you want to have a little chat, well, we're going to be here. But for those at the university, have a safe journey home. Bye-bye now. Okay, am I back with you at the university? Thank you, that's lovely.